to have you guys with us. We've been talking about exponents, and today we're going to extend that a little bit more. But remember, guys, if we're going to talk about numbers like these where we have x's and y's in the exponent, we need to make sure that we have like bases everywhere. So we know that in order to make sure that everything over here has the same base, we need to change all of these numbers to accommodate the same base. So I'm going to take each of these numbers, put them through my calculator, and I know I can rewrite 18 as 2 times 3 squared. What I'm going to do is I'm going to go to my calculator and I'm going to click 18 equals shift. And then I'm going to look for a button that has fact on the top. So I can write this as a product of its prime numbers. All right. So 18 is going to give me 2 to the power of 1 times 3 to the power of 2. All of that is going to be to the power of x multiplied by, I know that I can write 8 as 2 to the power of 3, and that 8 was already to the power of x plus 1. So this whole thing needs to be to the power of x minus 1. Sorry, not x plus 1. Over, I can then take 3 and rewrite it as 3 squared to the power of x plus 1 times, now I know 4 can be written as 2 squared to the power of 2x minus 1. All right, and then we just need to get rid of the brackets. That's step number 2. Step number 1 was finding like bases. Number 2 is take away brackets. All right, and wherever we see a bracket and an exponent, we know that we're going to multiply each of the exponents inside the bracket with the exponent on the outside. So we're going to distribute that. Now over here, remember guys, it's like almost putting that in brackets. So we're going to distribute like that. Same over here. If we put that in brackets, we're going to distribute that way. And over here as well, put that in brackets and distribute like that. All right, so I should get 2 to the power of x multiplied by 3 to the power of 2 times x will give me 2x, multiplied by 2 to the power of 3 times x, that's 3x, minus 3 times 1 is 3, minus 3. Over, at the bottom, I'm going to get 3 to the power of 2x plus 2, 2 times x, 2 times 1, multiplied by 2 to the power of 2 times 2x will give me 4x, and 2 times negative 1 will give me negative 2. All right, now I can see over here on the top that I've got two like bases being multiplied. So I'm actually going to add, I'm going to keep my base and add the exponents. All right, so 2 and 2, I'm going to keep my base of 2, and then I'm going to add my exponents. X plus 3x will give me 4x. And then there's a minus 3 that needs to come with us. And then at the top, I've still got times 3 to the power of 2x. All of this is over 3 to the power of 2x plus 2 multiplied by 2 to the power of 4x minus 2. All right, I'm going to continue over here, guys. All right, now I can see that I've got like bases. I've got a 2 and a 2, but they're being divided this time. So instead of adding the exponents, I'm going to subtract them from each other. So I'm going to have 2 to the power of 4x minus 3 minus, then I'm going to open brackets and I'm going to put the 4x minus 2 in brackets. And those brackets are very, very important, guys. Do not forget them. Multiplied by 3 to the power of 2x, which is this one over here. That 3 over there minus that 3. Because they're being divided, I'm going to subtract exponents. 3 to the power of 2x minus, and in brackets, 2x plus 2. All right. Now I'm going to distribute. I'm going to distribute this negative into my brackets for each. I'm then going to get 2 to the power of 4x minus 3 minus 4x. And then a negative and a negative will give me a positive 2 on the end there, times 3 to the power of 2x. And if I multiply in negative times 2x will give me minus 2x. And a negative and a positive will give me minus 2. All right, and then we're just going to clean up. We're going to add like terms on the top here. I'm going to get 4x minus 4x, that will give us 0. And then I've got negative 3 plus 2. And that's going to give us 3 to the power, not 3, 2 to the power of -1 multiplied by 3, and then we need to go see what's happened with the 3's here. 2x minus 2x will give us nothing, and then I'll end up with -2. Now, guys, can I leave my answer with negative exponents? Can I do that?
No, ma'am.
No, I can't. I can't. So I'm going to put this whole thing over 1, and I'm just going to take everything with a negative exponent, put it in my denominator, and I'm going to take the 1 and bring it to the top. So my answer will be 1 over 2 to the power of 1 times 3 to the power of 2. And this is getting really messy. I just realized I ran out of space and now it's looking really messy. 1 over 2 times 3 squared. 3 squared is 9 times 2 is 18. So my final answer will be 1 over 18. All right, and that's how we're going to start today's lesson. Can everybody give me a thumbs up? Does everybody understand what ma'am has just gone through? Give me a thumbs up. How are we doing? Amanda says, isn't it 4x minus 3 because you multiplied it with a negative? Amanda, where are we talking about, my darling? Where have I lost you? Okay, so what we've done, Amanda, is we've taken 4x minus 3 minus 4x minus 2. All right, so we always subtract top minus bottom. All right, so it should be a 2. It's a 2 and not a 3, my darling. Okay, it was minus 2 and not minus 3, so minus 2. Okay, are we all right there? Okay, good stuff. All right, peeps. I hope everybody's had a good week. I'm going to tell you guys, my week has been so long and my days just never end. I feel like this life is trying to kill us, guys. I'm going to be very honest. Yeah, my weeks are rough. My weeks are very rough. My days are rough. All right. Can we get into some of what we're going to do today? Yeah, Palisa, I feel you. It's like this whole life is the enemy. It's the enemy of progress. This whole life is the enemy of progress. I don't know. Yeah. All right, guys. Okay, let's get into a little bit of what we're going to be doing today. And this is not lesson 1 of 2. This is lesson 2 of 2. All right. I'm going to ask us a simple question here, guys. If I gave you guys the algebraic fraction 4x squared minus 6x over 2x, how would we solve for this? Who's got an idea? If I said to you guys, simplify this, simplify. How are we going to start this? Whenever we see algebraic fractions, what would we do? I'm hearing 2 ma'ams. I'm going to let any of you tell me the answer.
Wouldn't you have to factorize first?
Beautiful. Absolutely. We'd have to factorize the top. Yes. Mandisa, do you want to factorize the top for me, my darling?
Okay, ma'am.
What kind of factorization would we do?
Isn't that highest common factor?
It is. I'm going to ask everybody, including you and everyone in the chat. Everyone, you can pop your answer in the chat, guys. What is our default setting?
Ma'am,
Do you remember
isn't it the difference of, ma'am, isn't it the difference of 2 squares?
No, my darling. Remember, the difference of 2 squares would require us to have a squared number over there as well. So it's not going to be the difference of 2 squares. I'm going to ask everyone again. Mandisa, do you remember? And whoever unmuted, do you remember what is our default setting?
Restrictions.
Not restrictions. Have a look in the chat because Desmarie and Sia remembered, and I owe you both a high five. You guys are just...
It's the end.
Thank you. Our default setting whenever we're factorizing is to first look for an HCF. That's the first thing we're always going to check for. Even if we think it's dots, even if we see dots somewhere, we always check for HCF first. So, Mandisa, do we see HCF at the top here?
Yes, ma'am.
Yeah, why are you drawing on my screen now? Hi,
Ma'am, wouldn't the HCF at the top be 2x?
Absolutely, it's 2x. Good. So we're going to take 2x out as a common factor. Sia, I unfortunately can't erase what you've put on the screen. Can you erase it for me, please? Okay. If I take it out, what would I have left?
You would have 2.
Mm-hmm. 2 what?
X. No.
Good. X
Oh,
minus.
minus 3.
Beautiful. Good. Over 2x. Okay. Then what would we do next? Remember, it's an algebraic fraction. What would we then do?
Cancel. Would you cancel, ma'am?
Yes, whatever we find on the top and on the bottom that's common, we would then cancel, right? So we cancel. Sia, just try again for me, please. Try again, see if you can do that for me. Good. So my final answer is going to be 2x minus 3. Are we in agreement, Mandisa?
Yes, ma'am.
Good. All right. So we remember how to do this, right? And now when we get to exponents, when we get to factorizing exponents, absolutely nothing is going to change. We're going to do the exact same thing, guys. We're not going to do anything different. Sia, don't worry about it. I'll live with the little drawing on my screen. It's not a big deal. Okay. So what we're going to get now is a question that looks like that. All right. Now, I know that I can't now compare like bases from top to bottom. And the reason I know this is because there's a minus in between, just like the question that we did above, right? Okay, I'm just trying to see if I can maybe remove this part here. There we go. There we go. I got it. Excellent. All right. So I know that there's a minus, just the same way that Mandisa's just factorized for us. When she said we've got 4x squared, she said we've got 4x squared minus 6x over 2x. She didn't do this. She didn't go 4x, 4 and 2 will give us 2, and x squared and x will give us x. She didn't do that, right? First, what she did was she factorized. She factorized first. So that's exactly what we're going to do here. We're first going to factorize, but because these things are kind of put together, we can see that there's a 3 to the power of x plus 1. What we're going to do is we're first going to split and then factorize. Okay, so I'm going to ask you guys, pop your answer in the chat for me. When we see exponents with a plus or a minus in between, what is the instruction? What must we do? We must what? It's written on the screen, guys. Tell me in the chat if you want to unmute and tell me. Go ahead and tell me. What do we do whenever we see that there's a fraction with exponents and a minus in the middle? I'll give you guys another hint. It's this instruction. When there's a minus in the middle, what do we need to do?
Split and factorize.
Split and factorize. All right. And I'm going to explain exactly what split and factorize means in just a little bit. All right, let me ask you guys another question. If I gave you 2 to the power of x multiplied by 2 to the power of 2, we agree that like bases are being multiplied. So I'm going to keep my base of 2. What am I going to do with my exponents, guys? Good, Balisa, that's it. We're going to add. So what am I going to get if I add my 2 exponents? What will I get on the top? 2 to the power of?
X plus 2.
What are we thinking? X plus 2. Remember, it's not going to be 2x, guys. 2x is like when I go 2 times x. I can't go 2 times x. I'm adding my exponents. So I should get x plus 2. Right? I should get x plus 2. Now, what we're going to do in this part over here, when we split, is we're going to work in the opposite direction. So imagine I gave you 2 to the power of x plus 2, and I ask you to split it. How you're going to split it for me is you're going to go 2 to the power of x times 2 to the power of 2. Give me a thumbs up. Does everybody understand what ma'am has done here? I've just done it in the opposite direction. Is everybody okay with that? Excellent. Good. Let me ask another one. If I give you guys 5 to the power of x minus 1, how would we split 5 to the power of x minus 1?
5 to the power of x times 5 to the power of -1.
Beautiful. Yes, 100%. 5 to the power of x multiplied by 5 to the power of -1. And that's what we're trying to do here. All right. So let's go ahead and split that part. I've got 3 to the power of x plus 1. How would we then split that? What would we get there?
3 to the power of x.
Good. Both of you keep going. Times?
3 to the power of 1.
Good. 3 to the power of 1 minus 2 times 3 to the power of x over 3 to the power of x times 2. All right. So now what I want us to do, we've done the split part, which is lovely. We've done the split part. Now I want us to factorize. I'm going to ask one more time, guys. What is our default setting when we are factorizing? What's our default setting? HCF. Beautiful. Wonderful. It's HCF. Let's go to the top over here. These are two separate terms. Because there's a minus in between, we see two separate terms. Do these two terms have a common factor?
Yes, they do.
Yes, they do. What is that common factor on the top there?
3 to the power of x.
Good. 3 to the power of x is common over here, and it's common over there. They both have 3 to the power of x. So we're going to take 3 to the power of x out as a common factor. So I'm going to end up with 3 to the power of x on the outside. If I take that out, I'm going to have 3 to the power of 1 minus 2 left on the top over 3 to the power of x times 2. Okay, remember this is an algebraic fraction, guys. Now, do I see anything common on the top and on the bottom that I can cancel?
3 to the power of x.
Yes, the 3 to the power of x, exactly. So I can then do this. Cancel. So what I now have left is just the numbers. I know that 3 to the power of 1 is just 3. So on the top, I've got 3 minus 2 over 2. And then I just have to do the simple math. 3 minus 2 is going to give me 1 over 2 at the bottom. So my final answer is half. Give me an emoji in the chat. How are we feeling? It doesn't have to be a thumbs up, thumbs down. Give me an emoji expressing how we're feeling about this kind of question. How are we doing, guys?
Ma'am,
Yes.
don't we add 1 on top of 2? Like to just add these exponents.
Well, we don't have to because they're not the same base and we're minusing them.
Oh, okay,
Okay.
ma'am.
What I mean. So it doesn't really matter. We're just minusing two numbers, so it won't make a difference.
Okay,
Okay.
ma'am.
All right, my darling. Okay. Yes. And Sia says another one. I feel like we should try another one. Absolutely. Let's try another one. Okay. Of course, I'm going to explain again, but Desmarie, I'm going to use a different example. Is that okay? Can I use a different example? Yes. The exponents, remember, Buikanyo, 2 to the power of 1 is the same as 2. It's just equal to 2. So it doesn't really make a difference in that case. Okay. And 3 to the power of 1 is just the same as 3. So it won't really make a difference. We're just minusing numbers from each other. Okay. All right. Here's another one. Let's try this one. 3 to the power of x plus 1 plus 2 times 3 to the power of x plus 2 over 7 times 3 to the power of x. All right, so I know that I can't just cancel, 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 cancel everywhere because there's a plus in the middle. Because there's a plus in the middle, right? So my instruction is I have to split and factorize. I must split and factorize. All right. So let's try split and factorize. No, we don't have to, Kat. Okay, let me explain why. Okay, if we look at the final answer, after we've canceled the 3x and the 3x, do you see how we've only got numbers left? We've only got numbers left, yes? There's only numbers.
Yes.
So there's no need for us to then have to do the whole 3 to the power of x with the exponents anymore. As a matter of fact, I could just take this and punch it into the calculator and my teacher will still give me the marks. Okay, as long as there's no more x's in my exponents, I can just put that into a calculator and get an answer. Does that make sense, Kat?
Yes, it does. But ma'am, like I don't really understand because like the fraction you gave us, right? We could use like the laws of exponents, but like I just don't wanna understand why we didn't like and chose to use the factorizing method.
Okay, because there's a minus in between. Because there's a minus in between. All right, let's go back to that first question we did. Were you here at the very beginning of the lesson, Kat?
Yes, ma'am.
Okay, so let's go back to the top. Do you see how this question here at the top, my darling, has multiply and multiply?
Yes.
So when I'm multiplying things, I can definitely just cancel like that, top to bottom. I can do that because there's a multiply in between them. It's no problem. But over here, because in my fraction, I have a minus or a plus in between, I first have to factorize and then cancel. Are you with me?
Oh, yeah, I do see it now.
Okay, we good.
Yes.
Excellent, good stuff. Good. All right, let's look at this question over here. Okay, Kat, I'm going to ask you again. Can I cancel top to bottom in this particular question?
No,
Why not?
because there's an addition sign in the middle.
Beautiful. Just mwah, mwah, mwah. If you were sitting in my class right now, I'd give you a lollipop because I bribe my kids with lollipops every time they get correct answers. So a lollipop for you, Kat. Here we go. A lollipop for you, my darling. There we go. For Kat. Because she's such a star. You're very welcome. Ah, beautiful work. Good. There's an addition sign, so we can't do that. So what we need to do is we need to split and then factorize. Kat, do you want to split this first one here for me? This 3 to the power of x plus 1. How would we split that?
We would say that 3 times 3 to the power x times 3 to the power 1.
Beautifully said, my girl. Plus 2 times, split the next one for me. I know you can do it.
3 to the power x times 3 to the power 2.
Beautiful. Do I need to split at the bottom?
No, I don't think so.
No, because there's already a multiplication sign at the bottom, right?
Yes.
Good. And then I can go times 7 to the power of 3 to the power of x. Now at the top, I've done the split part. What's the next step?
We factorize, I think.
Correct. We must factorize. Good. Now, what is our default setting? Every time we're factorizing, what must we look for first?
The highest common factor.
Absolutely. HCF. Right. Now, if we look at this top part over here, there are two terms, yes? There's the first term and there's the second term. What do they have in common?
3x.
Yes, not 3x, it's 3 to the power of x, but we know where Amanda was going with that. Yes? 3 to the
3 to the power x.
Good. So we're going to take 3 to the power of x out as a common factor. What do I have left if I take it out?
We have
Let's
3
start.
to the power 1.
Good.
And 3 exponent 2
And
positive 2.
good. So I've taken out the 3 to the power of x's. So I've got 3 to the power of 1. Don't forget the plus sign, hey? Plus,
plus 2
left on this side, I've got 2 times
times
3 to the power of 2.
squared.
Agreed?
Yes, I do.
Good. Over 7 times 3 to the power of x. Now that I've factorized, I've got a fraction. Do I see anything on the top and on the bottom that I can cancel with? What's the same on the top and the bottom?
3 to the power x.
Beautiful. So I can take 3 to the power of x and 3 to the power of x and cancel them. What do I have left now?
We have 3 exponent 1 plus 2 times 3 squared over 7.
Beautiful. Do you see how I only have numbers now?
Yes, I do.
So I can just figure out what the numbers would be, how much that would be as numbers, right? So I can go 3 to the power of 1 is just 3. Do you agree with me?
Yes, I do.
Good. So I've got 3 plus 2 times, what is 3 squared?
It's 9.
Good. So I've got 3 plus 2 times 9 over 7. Let's do the top part for me. I know 2 times 9 is going to give us?
It's going to give us 18.
Good. It's 18. Good. Oh, thank you, Sia. Good. So on the top, I've got 3 plus 18. How much is 3 plus 18?
It's 21.
Divided by 7.
21. Is it 3? I'm not
Yes,
sure.
look at that. Our final answer is 3. How cool is that?
It's very cool. It's very cool.
Well done, Kat. Amazing stuff. And Sia just handing out lollipops on my behalf. I love it. Well done, Kat. Amazing stuff. Everybody else, give me a thumbs up, thumbs down. How are we feeling? I feel like these questions get really nice, especially when we understand what we're doing. Hey? How are we feeling, peeps? Beautiful. Well done, Langelihle. That's it, Buikanyo. It is getting easier. I agree, Sia. I agree. There we go, Desmarie. Can we do another one? Would we like to do another one? Yes? I think we can do one more. Yes, absolutely. Let's do one more. All right. Here's our next one. I'm going to give you guys some time to do it yourselves. All right? Here's our next one. 3 to the power of x plus 1 plus, oh, this one is too easy. No, don't write it down. It's too easy. I feel like no. It's too easy. Okay, here's another one. 5 to the power of a plus 4 minus 5 to the power of a plus 3 over 5 times 5 to the power of a plus 1. Now, I know that I can't just cancel the top and cancel the bottom. Why do I know that? Who can remind us? Why can I not just take things from the top and the bottom and cancel? Who remembers?
There's a minus sign involved.
Yes, yes, absolutely. Because there's a minus in between. So what do I need to do, guys? What's the instruction? I must?
Split and factorize.
Yay, Sia, beautiful, good. I must split and factorize. Good. So I'm going to give you guys a moment to split, and then I want you guys to factorize for me, please. Once you're done, guys, you can pop your favorite emoji in the chat. Let me know how everything went. Yes? Amanda, that was super quick. Well done, Desmarie. Sure. You guys are just like flying, flying, flying. I love it. Isn't it nice when you understand the maths and it starts flowing? It's such a nice feeling, isn't it? I like it. Yeah. Once we know exactly what we're doing and we just like, and you're like, yes, I am the king or the queen of the world because the maths is just so lovely. Makes me feel very nice when I know what I'm doing. Yeah, it's the best feeling. All right, we'll give everybody else a few more seconds and then we'll get started. Amanda, it could never swallow you. You're too great a maths warrior for maths to swallow you. We're slaying the maths dragon. We will always win. We'll always come out on top. All right, peeps, let's have a look at this one. Okay, I'm going to split. I know that I can't just cancel. There's a negative in between. So I'm going to split. I'm going to get 5 to the power of a times 5 to the power of 4 minus 5 to the power of a times 5 to the power of 3 over 5 times 5 to the power of a times 5 to the power of 1. Right. Now, I know that's the split part done. I now have to factorize. What kind of factorization am I going to use, guys? Who's got the answer for me? On the top, what kind of factorization are we using?
Is it not HCF?
HCF.
It is. It's absolutely HCF. I'm going to take 5 to the power a out. They have 5 to the power of a in common. Good. So I'm going to take out 5 to the power of a. And if I take that out, I'm going to have 5 to the power of 4 minus 5 to the power of 3 over 5 times 5 to the power of a times 5 to the power of 1. Now, I now can see something on the top and on the bottom that is common. I see 5 to the power of a and 5 to the power of a. Right. Now, what I have left is 5 to the power of 4 minus 5 to the power of 3 over 5 times 5 to the power of 1. Well, this one is also 5 to the power of 1. Now, I know that this is going to be like a big tricky number. I'm not going to be able to find it. Guys, pick up a calculator and just put that in. Pick up a calculator, put in 5 to the power of 4 minus 5 to the power of 3 over 5 squared. What do I get?
Ma'am, it's 500 over 25. And it'll give you
500 over 25, which is?
20.
20. There we go. Beautiful. The answer is just 20. Okay, give me how I'm feeling in the chat. Is it good? Is it bad? Or is it meh? Mandisa, how are you feeling? You can tell me because you're already unmuted. Tell me.
Ma'am, I understand it. Now.
Okay. Now, okay. I'm going to take that as a good, ma'am. I'm feeling good. Yes?
Yes.
Okay, beautiful. Excellent. Guys, tell me, how are we feeling? Good, bad, in between? Yeah. I feel like we could do another one. We could stand to do another one. Nice one. Oh, no, Sia, do not doubt yourself. If you know what you're doing with the maths, it's always going to come out right, dude. Okay, good. All right. Can I then introduce something a little bit different? Can I? Can I do that? All right, let's learn something. I'm gonna have to. I'm sorry, my darling. I'm so sorry. Okay, let's split this. How would I split? Sorry, Amanda, I will try. I will try to make it nice and easy. Okay, let's split 3 to the power of 2x. How would I split 3 to the power of 2x? Okay, are we all in agreement? 2x is the same as x plus x. X plus x would give me 2x. Yes? So if I had to split 3 to the power of 2x, how would I split that?
X to the power, 3 to the power of x plus x.
to the power
Good.
of
So I'll go 3 to the power of x times what? Times
3 to the power
The
of
power of x.
x. Good. That's it, Amanda. Good, Mandisa. That's it, Sia. 100%. That's how we're going to split it. All right. So I'm going to give us a question. This is our question. Our question is going to read 9 to the power of x minus 1 over 3 to the power of x minus 1. Or let's say plus 1. All right. Now I've got two problems. First of all, I can't split anything, right? But also, I don't have things that are the same base. This is a 9 and this is a 3. I do know, however, that I can change one of them to have a base that looks like the other. Which one can I change?
The 9.
Good, I can change the 9. How else can I write the 9?
3 to the power 3 to the power of 2.
Good. 3 to the power of 2. I can write this as 3 to the power of 2. Okay. So I'm going to rewrite 9 as, in brackets, 3 to the power of 2. But it was already to the power of x. So the x needs to sit there. Minus 1 over 3 to the power of x plus 1. It's all good, Amanda. I knew exactly what you meant. Right. Now I see a bracket and an exponent. So I'm going to multiply my two exponents. And that's going to be, I don't know why I erased this. I should have left it there. Is equal to 3 to the power of x times 3 to the power of x. Now I'm going to get 3 to the power of 2x minus 1 over 3 to the power of x plus 1. Okay, can we now split 3 to the power of 2x?
Yes, we can.
Yes, we can. We can split it into 3 to the power of x times 3 to the power of
3 to the
x.
power of x. And then we cancel.
Over 3 to the power of x plus 1. But Mandisa, we can't cancel. Why does ma'am say we can't cancel?
there's a minus sign over there.
Ah, yes, Sia. A lollipop for you, sir. Well done. Even though yours comes with colors. Good. This lollipop is for Sia because Sia remembered that there's a minus sign and a plus sign at the bottom. Right. So what we're going to do is we're going to use K substitution. Do we remember K substitution? Do you remember K substitution? Palisa, I promise it's going to make things so much easier. All right, let me show you guys what I'm going to do. I'm going to do this. I'm going to say, let K be equal to the thing that's most common. In this case, it's going to be 3 to the power of x. So in this equation, wherever I see a 3 to the power of x, I'm going to replace it with K, right? So I'm then going to get, there's a 3 to the power of x, I'm going to get K times another 3 to the power of x will give me K minus 1 over, there's another 3 to the power of x, so I'm going to get K plus 1. Now I know that K times K is just the same as K squared. So now I've got K squared minus 1 over K plus 1. What kind of factorization am I looking at up top here?
Difference of 2 squares.
2 squares.
Yes, absolutely. Who said that? Was it you, Kat?
Yes.
Yes. Yes, it's a difference of 2 squares. Well done. Another
Yeah,
lollipop for Kat. I'm gonna give Kat cavities today. Another lollipop for Kat. Well done. Yours will have polka dots. Nicely done, Kat. There we go. A lollipop for Kat. Well done, Kat. Excellent. It's a difference of 2 squares. So I'm going to factorize this as K minus 1 and K plus 1 over K plus 1. Now, do I see anything on the top and on the bottom that I can cancel?
The
it's
K minus 1. I mean K plus 1.
The K plus 1, right. So the K plus 1 and the K plus 1 will cancel. Now what I have left is K minus 1. But I know that K was equal to what? What was K actually equal to?
3 to the power of x.
Excellent. So my final answer is 3 to the power of x minus 1. There's my final answer.
Well, actually, I
How
love
are we
to do
feeling?
this.
Yes, absolutely. You're allowed to do case substitution whenever you feel like it, sir.
Yeah.
All right. How did we feel about that, guys?
That's nice.
It's nice. Case substitution works for everything, even the ones we did before, the ones where we were taking out an HCF, you can use case substitution for those as well. Okay, can I give you guys another one? I want you guys to
Yes,
try another
ma'am.
one for yourselves.
Another
All right.
one like this one, because you're
Yeah, yes, absolutely.
ma'am.
Let's do it. Okay, I'll give you one. Here we go. 25 to the power of x minus 36 over 5 to the power of x minus 6. Right. What do we notice here, guys? Do I have things with the same base?
No, you don't.
No, we don't. But we know that we can change 25 to what?
5 to the power
5 squared.
5 squared or 5 to the power of 2. Absolutely. So let's go ahead and do that. We're going to get in brackets 5 to the power of 2 to the power of x minus 36 over 5 to the power of x minus 6. I see a bracket and an exponent, so I'm going to multiply these two. So I'm going to end up with 5 to the power of 2x minus 36 over.
Ma'am, 36 can also be
And the
36.
30,
I was also
Am I
going to
moving
say
too
that.
fast? Am I moving
Yeah.
too fast?
No,
No,
ma'am,
36
can't
can also
36
be
36.
5.
Can I?
Yes,
Square the 36.
squared. 36 squared.
Yes, 36 is indeed 6 squared. We could make it 6 squared, guys. But remember, the point of this is for us to factorize, right? The point is for us to factorize. So I don't necessarily think changing 36 into 6 squared is going to change much at this point, okay? Because remember, we're going to get dots. We're going to get dots, and then we're still going to use it as 6 squared. If it helps you to change 36 to 6 squared, you can absolutely do it. You and I are going to end up with the same answer, okay? You can do it if you like. It won't make a difference, all right? Is that okay? Can I leave it, or do you want me to change it to 6 squared?
It's fine, ma'am. Carry on.
Can I carry on? You'll see, we're going to end up with the same answer even if we make it 6 squared. All right, let's talk, guys. How am I going to split 5 to the power of 2x?
5 to the
gonna
power
be
of
5
2
to the
times 5x.
I can't do
That's
this.
gonna
I
be
can't go
5
5 to
to
the power of 2 times 5 to the...
5x times 5x.
Yes, good. Mandisa, check
Oh,
what happens. If I split it like this, I'm going to end up with, like bases being multiplied, I'm going to end up with 5 to the power of 2 plus x.
2
That's
plus
not the
x.
same thing as 2x, is it?
yes, ma'am.
Oh, it's not. It's not. So we
I mean,
can't
no,
split.
ma'am.
All right. So be very careful, guys. When we split 2x, we must split it as x plus x, not 2 plus x. All right. So we must get 5 to the power of x times 5 to the power of x minus 36 over 5 to the power of x minus 6. Then we're going to say, let k, what are we going to let k equal here?
5 to the power of x.
Good. Let k equal 5 to the power of x. So that's then going to give me k times k minus 36 over k minus 6. We're all in agreement k times k is?
8 squared.
It's good.
Good. K squared minus 36 over k minus 6. What do I see at the top? What kind of factorization?
Dots.
Dots. Good. It's difference of 2 squares. So we're going to open 2 brackets. I'm going to go open, 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 open. K minus 6, K plus 6. Do you see, ladies, why it's not necessary for me to change 36 to 6 squared?
Yes,
Not
ma'am.
necessary. I'm still going to get to the exact same answer. All of that over K minus 6. Do we say something we can cancel?
K minus
K
6.
minus 6.
K minus 6, good. K minus 6 and K minus 6. So my final answer is then K plus 6. But we know that K was actually equal to
5 to the
5
power of
to
x
the power of
plus
5 to the power of x plus 6. What
Ma'am,
time
do
did
we
Woohoo!
ma'am, do we just end it like 5x plus 6? Or can you
Yes.
just end it? Oh,
Okay, you can't end it with k plus 6 because remember our original question didn't have k in it. Hey, we introduced
yes.
k. So we can't leave it with the k in there. We must finish it off properly.
Ma'am, must it always be K or can it also be another letter?
Yes, ma'am.
It can be D, as long as it's not X. Don't make it X because X is part of the question. Okay,
Oh.
so you can say, let M equal 5 to the power of X. Let D equal 5 to the power of X. It's fine. It's fine. We're going to get to the same answer. Okay. Can I step it up a notch? Yes?
Yeah, we can.
Yes, ma'am.
I feel like people are going to be like, yo, ma'am. Hi, ma'am, slow down.
Ma'am,
I
K
know.
already hit me, ma'am.
Okay, sure. Let's try something else. Okay, here's another one. All right. This one says 9 to the power of x plus 3 to the power of x minus 2 over
Ma'am.
9
Ma'am,
to
you're
the
just thinking
power
of what?
of
Ma'am. No.
Oh, ma'am.
I'm sorry, guys.
Yeah.
I'm sorry. I'm sorry. But I promise you guys, we're going to see it. I promise we're going to see it. It's not that bad. I promise. Okay. I know that I don't have like bases. Yes. I don't have like bases. So we're going to change nines. We're going to change both the nines. What are we going to change them to?
Brackets
3 squared.
3 squared times the
Good.
x.
Excellent, beautiful. And see, I love how you said bracket 3 squared times the x. Good. So that one is going to become 3 squared to the x plus 3 to the power of x minus 2 over, at the bottom again, bracket 3 squared to the power of x minus 4. Okay, let's multiply in. I've got a bracket and an exponent, multiply, bracket and an exponent, multiply. All right, so I'm going to end up with 3 to the power of 2x plus 3 to the power of x minus 2 over 3 to the power of 2 times x, that's 2x minus 4. Are you guys still with me? Are we all good?
But
Yes,
Good.
ma'am.
All right, let's split the 2 x's. Okay, how would I split the 2 x's? 3 to the power of?
X plus
X
times 3 to the power x.
Good. Plus 3 to the power of x minus 2 over 3 to the power of x times 3 to the power of x minus 4. What's our next move, guys?
S substitution.
Good. K substitution or S substitution or M substitution,
P for
whatever you
Palesa, ma'am.
Palisa?
Ma'am, you can just say let P be 3x.
Hey, good. Let P
I already
equal.
said S.
Okay, all right, okay. Okay, can we take a vote? Who says
S,
P?
ma'am.
Is S okay?
M.
Can we use S? All right, let's use S. See how you win. All right, let S equal to, what are we going to make it equal to?
3x.
3 to the power of x.
Good. So now we're going to get S times S plus another 3 to the power of x, that's S, minus 2 over, what are we getting at the bottom?
S.
S times S
S.
minus 4. Let's clean it up, guys. What is S times S?
S squared.
S squared plus
Plus.
S minus 2 over S times S will give me
S squared.
Minus
S
4.
squared minus 4. Let's start with the top. What kind of factorization are we looking at the top?
A trinomial.
It's a trinomial. Yes, and at the bottom, what do I see at the bottom?
Difference of 2 squares.
Difference of 2 squares. Correct. All right, so we're going to factorize the top as a trinomial. And we're going to factorize the bottom as difference of
Dot.
2 squared. As dots. All right. See, I told you guys it wasn't that bad. It's not that bad, right? Okay, let's factorize the top. Over here, I'm going to get S and S. And then I need factors of -2 that are going to give me positive 1s. What are those numbers? What are the factors of 2, guys? 1 times?
1,
2.
2.
Good. I need to get positive 1. So which one is going to be positive and which one is going to be negative?
2 will be positive.
And 1 will be
Good.
negative.
Good. So I'll get +2 and
Minus
-1. Good. Then at the bottom, let's factorize dots. What would the difference of 2 squares look like at the bottom there?
S minus 2, X plus 2.
Excellent. S minus 2 and S plus 2. Let me just clean this up. I feel like I've made a mess there. My OCD is kicking in. All right. Do we see anything at the top and at the bottom that we can cancel?
S plus 2 and S.
Good. S plus 2 and S plus 2. That one and that one. Good. So my final answer is S minus 1 over S minus 2. But Sia, what did you say S minus 1 or S is equal to?
3 to the power of X.
Beautiful. So we're going to get 3 to the power of X minus 1 over 3 to the power of X minus 2. Ta-da! Woo-hoo! That's it, guys. That is it.
So, ma'am, I have a
You.
question.
Yes.
So, okay, in class, my maths teacher told me that, like, if we have like numbers that have indices, right? We have maybe like 25 made to the power x, right? We have to
Mhm.
change it to like prime numbers before we can
Yes.
actually, yeah, do that. So
Yes. Mhm.
on this example, right? 4
Mhm.
is a prime number. But then, like at the end, right, we ended up getting dots, right? So on
Mhm.
my side, when I actually solved it while you were solving it, so I got to the answer before you guys. But then
Okay.
the difference is that I actually changed 4 to 2 squared, right? So I wanted to
Mhm.
ask if maybe after like substituting k,
Mhm.
I used like I said k squared minus 2 squared. Is it wrong or did I have to change like 2 squared?
No. Not at all, my darling. You're actually correct. Remember, dots actually stands for the difference of 2 squared numbers. Yes? 2
Yes.
squares. So even if we write k squared minus 2 squared, do you see how both of these things are squared? It even makes it a little bit easier for us to see the dots because I know that I just need to put a k, a 2, and a 2. The only difference is the signs. So even if you do that, my darling, the answer is going to be 100% correct. There's nothing wrong with what you've done at all.
Okay.
Okay. Well done, my darling. That is absolutely 100%.